Hello, your friendly neighborhood Mr. Stone here, and today we are going to be talking about hypothesis testing and what exactly that means. And we've heard about a hypothesis, I'm sure, in science class, but we haven't really talked too much about this in statistics just yet. And here's how this works. Suppose you have some sort of theory. So, for example, my theory might be that, I don't know, let's say that Tom Hanks is an alien. All right, so Tom Hanks is an alien. That is my theory. I could call this, in this case, a null hypothesis. This is kind of like the idea that I want to test. Okay, this is my null hypothesis. And in order to test this, we need to have an alternative hypothesis because these two are going to be mutually exclusive. Okay, mutually exclusive, again, that just means that I can choose one or I can choose the other. These two are both mutually exclusive. I cannot have both. I cannot have Tom Hanks be an alien and not be an alien at the same time. That just would not make sense. The null hypothesis uh, is frequently called H naught. Okay, this is not ho, this is H naught. That's actually a little zero down there. There is no Santa Claus right there. He is not in this picture. Let's give him a little hat right there. There we go. And he is, oh, don't forget the beard. Oh, don't forget the beard. Okay, that's a terrible, oh, he just looks like a werewolf now. All right, okay. So we don't have a Santa Claus werewolf. This is H naught. And our alternative in statistics we call the alternative hypothesis, and that's usually down there as just H-ah. This is not ha. If it helps you remember them by thinking of sounds that people make when they laugh, go ahead, but this is H naught, and this is referred to as H-A. All right, H sub A. So, again, mutually exclusive, either you've got your null hypothesis is true, and we accept it, or we reject it and we tell it to go away and we just don't believe it. That's really what the hypothesis testing is. You have a null hypothesis, you either accept it as being true or you reject it. Now, getting away from movie stars and extraterrestrial life, let's think about how this could play out in terms of statistics. So, quite frequently, a null hypothesis is some sort of claim that we want to make to see if it is true. So let's say, for example, we want to think about something like this. Let's say the mean number of texts sent by a teen in the US is what sounds like a good number. 142. I like that number. Okay? So, if this is my claim that I want to investigate, I'm going to set up a null hypothesis. My null hypothesis, my H naught, is simply, or excuse me, I said H naught, but I put an N. My handwriting isn't that bad. My H naught is just that the mean number of texts, and I'm going to just put down a mu for that, is equal to 142. Now it doesn't have to be equal, but I do need to have some sort of equality in there. So I could do, I could say it's actually less than or equal. Okay, I could have gone something like that. I could have gone greater than or equal, as long as it's got that equal component in there, and I do have that here with my equal sign, that the mean is 142. Okay, so that's your H naught and your alternative hypothesis, your HA. This is simply stating some way that this is not true. It's got to be mutually exclusive, so it can't be the same thing. So if you're claiming that mu is equal to 142, that the mean is 142, then you could say, well, my alternative hypothesis is that, you know what? Maybe mu is less than 142. Maybe they're not texting all that much. Okay, this would be called a one-sided hypothesis here because it's really just talking about one side. If I draw a number line right here, there's my 0, there's my 142. We're really claiming that it from this point, oh excuse me, should be an open circle there. Oh boy. From this point it should be all the way down there up to, really it's got to be limited at 0 because you can't have negative text. That would be really weird. But you've got this space right here, and it's less than. I haven't said anything about where the text could be to the right. Okay, if I were, I could do another one where I would say that mu, these would be separate by the way, would be greater than 142, but that's also one-sided because in that case I would be looking at going from 142 to the positive direction. Okay, if I want to include a two-sided, then I would say something like mu, your mean, does not equal 142. So in that case, you're really covering everything. You're saying that, with the exception of the number 142, it could really be anything down this way. I mean, eventually up till 0, but that's because in this case we can't have negative text. That would be really weird. And it goes on for infinity in the positive direction there as well. It could be anything else. And again, note, these are mutually exclusive. If it's 142, then it is not less than 142. It is not greater than 142, and it would not be equal to 142 either. And again, these are 3 separate cases that I have put down here just for an example. You could have one other one. You could say that the average U.S. driver, let's say that they drive, I don't know, 28,000 miles per year. So you could have a null hypothesis, your H naught. What would you put down there? In this case, we'd put down mu equals 28,000. But let's change this. We've seen this format before. Let's now change it to drives more than 28,000 miles per year. Now what would it look like? With a little bit of line right there, that's changed slightly. Now we've got mu, your mean, is greater than or equal to 28,000. Okay, well, quite technically, I suppose I should do this. 28,000 or more miles per year. We've got to have that equality in there one way or the other. An alternative hypothesis would be, well, you can't have any overlap. You cannot say that anything that's not going to be mutually exclusive. Whatever you put down can't overlap. So if your H naught, your null hypothesis, is saying that here's 28,000, so closed circle there because we've got the greater than or equal to, goes off in that direction. So our alternative hypothesis has to go, again, 28,000, and we can't include 28,000 because that's part of our null. So it's got to go off that away so that we've got no overlap. These have to be mutually exclusive. So in this case, we would write what? Mu is less than 28,000. All right. That's just a brief example of how to work with a little bit of hypothesis testing and null hypothesis. We will be talking more about this, and in the meantime, I hope you have a wonderful and productive day.